Okay, so let me just start with a short introduction of Raytheon. We're a big defense contractor, and we build lots of different types of systems. There are 4 different divisions in Raytheon. One of them is missile systems. Has anybody heard of Tomahawk missile? Happens to be one of ours. But Eric and I work out of the Intelligence and Information and Services division. So we work on intelligence systems, as you can guess. We also work on satellite ground stations. So we're working on the GPS next generation satellite ground station here in Aurora. We also work on things like JPSS, where Eric and I met, which is a big NOAA weather satellite that collects climate kind of weather. Our division actually has well over 100 different programs running at any given time. So they're small embedded programs like Air Soldier, which puts Google Glass kind of devices on soldiers' helmets to keep them aware of where their squad mates are in a firefight so that they don't shoot each other, to the very large intelligence systems that we work on. And unlike most IT organizations, our organization, since our customer drives much of the process, of those 100+ programs, every one of those programs could have a different process and different way that they approach things. But in general, right, my goal is to try to make them all more efficient. So this CALM or CALMS term, you'll find a couple different versions of it out in the literature or on the blogs. I think it was originally coined by Jez Humble, author of Lean Enterprise, which is a great book, and Continuous Deployment. But they stand for culture, automation, lean, and measurement. And sometimes there's an S on it for sharing the information between team members. So we're going to walk through these quickly. I think that it's really important as an architect to sort of change your thinking if you're trying to help your teams be more DevOpsy. So it's especially in organizations like Raytheon, you tend to get those white-haired guys that have been around for a long time that are the architects. And when I go out and engage with programs, I find that a lot of times the architects think that DevOps won't have anything to do with them, and they shouldn't really care. Just let me in my office to draw some diagrams and leave me alone. But I think that there's actually a pretty big role with respect to DevOps for the architects. And I think that suddenly we have a need for more architects because we need to do things like architecting test and architecting, really spending a lot of time to architect the deployment environments as well as the application. So I think that's all important. And in my organization, again, a lot of those white-haired architects don't like change, and that's really important, right? So we have to start at that level to embrace that change, to encourage the teams and move on. So one thing that I really like that an architect can do on these teams is to embrace experimentation. And you have to change a little bit if you're coming from a waterfall model that you don't want to spend 6 months or 9 months on some experiment and figure out that it failed, right? So an architect can really spend a lot of time figuring out what are the small experiments we can do and how do we go forward with that and encourage that culture of experimentation and celebrating the results of the experiment, whether they passed or failed. Right? That's a big change in the DevOps world. Let's see. The other thing is to really become part of the team, right? So I've been at Raytheon for 19 years. I started when we still wore, as women, high heels and nylons and skirts, right? Super easy to get into this place where you have to dress up. But you'll find if you go out and talk to like site reliability engineers, which is the way Google has approached DevOps, that they actually encourage nothing more than a t-shirt and jeans, right? That you have to be part of the team. You have to make the team feel like you're listening, that you're one of them and you're willing to work with them. And we see that in experience, right? When you go out and you're dressed up, you sort of set yourself apart from the developers. So think about those sorts of culture changes as well. All right, I'm going to hand over to Eric for a few minutes.
Can you hear me? It's good? Okay. So yeah, actually, for being Hasidic, this is actually dressing down, and all of the letters on my shirt are actually in white, so they're not easy to see. But I want you to know that we've done that. So yeah, so architect has an important role in terms of the automation part of Calm, right? So, and that can be divided up into three general areas. The first one, modernization of an application. That could be existing large-scale application, right? It can also be new applications. As a matter of fact, Amazon and Google themselves they're on their 5th major rewrite of their architecture, not just of their code, but an entire re-architecture of their systems. So there's a recognition that what architecture was good today is not necessarily good enough for tomorrow. And that includes doing things like breaking down monolithic software into microservices, containerization instead of VMs, because you have a finer grained control in terms of your scalability, in terms of moving and processes around to where you can achieve the proper results in user experience. But also the second aspect is deployment pipeline architecture. So a lot of times, and I'm sure I'm not the only one who has experienced this, is you come onto a program or you start a project and you find that people think of the deployment architecture as an afterthought or a support function. And really what we have found is that the deployment pipeline is actually a first-class citizen. It is integral to the ability to deliver software quickly and in smaller batches. And the last aspect that we need to think of in terms of our infrastructure, right? Because that is not just a support function either. That is an integral part of our release. Typically, we release the infrastructure along with our software. So I'm not going to go into every single pattern there is. If you want to discuss this more, I have office hours on Thursday. But one of the important patterns and tactics we see is using infrastructure as code. So why is infrastructure as code important? So number one, I not only need the ability to document all of my changes, that's nothing new, but I need those changes to be executable. I need the ability to reproduce them at will. And there are several tools for that. There's Chef, there's Puppet, there's Ansible. I have to prefer Ansible. The Puppet is catching up in terms of having a declarative language what will apply things that have not been applied yet. And you're not scripting, you're actually declaring what you need done. So when I describe my configuration, my security, my database configuration, my COTS and FOSS, my OS configuration via files, that enables me to put them into version control. When I put them into version control, I can describe them in a unique way at some particular point in time. And more importantly, just like I do with a software baseline, I can describe them all together by a singular version, such that when I instantiate it in my dev environment, in my test environment, in production, I can say that if I have version 1, 2, 3 in several environments, they should be identical. But in order to do that, I need to make sure that whenever I make changes to those files, that I make a new version. And that is what we call immutable infrastructure. That's where when I describe a particular version of my software, of my infrastructure, it is unique. So typically, whenever we branch our software, we do so in version control, in source control, right? So we need to control a particular part of our baseline, so we create a branch. Problem is as we increase our branches, we then increase the need to merge between those branches to keep them up to date. There's a bug fix here, now we have to put it over here, and it creates a nightmare for us, right? We spend more time doing that than actually doing development. Furthermore, that doesn't necessarily give us the control over what actually gets turned on in our production environment. So enter feature flags. Feature flags are simply a way to wrap our code in conditional logic such that we can turn it on and off with the setting of a flag. That enables us to dark launch into production, which essentially means that we can put a feature or fix or whatever it may be out into a production environment, but it will not be turned on. It's as if it wasn't even deployed there. And then we can turn it on in a controlled way on actual production servers, test it in a real production environment without impacting users, and then turn it off if something goes wrong, or leave it on and then actually remove the conditional logic at a later point. And this is a lot easier to manage, as well as giving us a lot of painless deploys very quickly into our production environment. So if we have versioning of our infrastructure, versioning of our custom software, so a change from 101 to 103 does not mean the same to everybody. I've seen software where major interfaces have changed going from 102 to 104. And then in others, a major version change had no demonstrable differences, right, other than little changes under the hood. Attached to your versioning a semantic notion, and there is actually a standard called semantic versioning, which itself is versioned. It's at 2.0.0, and it enables us to have a concept of backwards compatibility. Why is backwards compatibility important? Is that enables me to know if a microservice that I have deployed out, if I am upgrading that in a patch version, then I should be able to swap out, as a live deploy, swap out that live version with the existing version using a proxy front end, such that it is entirely seamless to consumers, right? And whereas if I change a major version, then that means that I have to wait until consumers that are compatible are trying to attach to that service before I allow them to do so through my proxy. Another aspect of change is also within our database. As much as we talked, there was a class yesterday in terms of having separate databases and so forth, nonetheless, even when you isolate out databases for your microservices, they may not be the same in all of your environments, right? This environment they may be testing this version of your software, and another environment, another version. So what do? You need to know you need to have a way to describe the particular version of your database that's running in an environment, and you also need to have a way to describe what changes need to be applied to go to some other version. So if I can uniquely describe that my database is at version 123, then I know that there is a set of changes that need to be applied to bring it to 135. How do we do that? We check in those incremental database changes along with the software changes they support, and then apply them in an automated way to bring our database up to a compatible level. And that's how we manage that. But along with that, there's also the concept of it still being a scary change to deploy out into production, right? So even with dark launching, there is the possibility that something will go wrong, and I'll need to turn that off. Problem is if I make a change to my database that's not compatible, now I have to go rolling that back, DBAs have to get involved, and it's not painless anymore. So there's a pattern from Martin Fowler called the expand contract pattern that enables us to achieve painless deploys and rollbacks, such that if at any particular point I need to roll back, my database stays in a state that is compatible with the previous version. The problem is that this really works effectively when you have small batches of changes. If you have a lot of changes that are going in, it is much harder to defer. If you're deploying once a year, it's harder to defer those changes that are not backwards compatible. So this really goes along with having small batch changes that we're deploying very quickly. Along with automation, also should not be a surprise, the ability to test our software in an automated fashion. And there are various tactics to do so. We want to isolate our software to achieve defect localization. Why is that important? Because with defect localization, I reduce my mean time to resolution. My developers can find the problem, find it fast, and fix it fast. That way, I am not left exposed, right? In order to isolate that, there are different tactics, which include mocking, service isolation, and also here on the right, we see what are called code seams. That's from a wonderful book called Working Effectively with Legacy Code by Martin Fowler, where he discusses code seams and the ability to use subclassing, preprocessing directives, and so forth to isolate out the parts that we don't want to test or that make it hard to test from the other parts without actually changing our code. Because if your code is not under test, then you have a chicken egg problem. Do you change the code, possibly breaking it, or do you actually get it under test first? And you want to get it under test first. The last thing, getting business logic separated from GUIs and disks, which is also talked about by Michael Feathers as well as others, enables us to have very fast test performance where we can execute our tests very quickly, getting a fast feedback loop to our developers. And then lastly, in terms of automation, we also have the concept of proxies, service discovery, and scaling of our software via what is called container management software. So it was brought up in the previous presentation about Kubernetes and some of the security issues that are with that. So OpenShift actually decorates Kubernetes, providing not only nice proxying and service discovery, but it also provides various authentication and security, fine-grained security controls on top of that. The other thing also why this is an important pattern is that all of those consumers, when they access a service, they access it via a particular address and port, right? But behind the scenes, that's actually being resolved via that proxy to any number of instances that can be scaled up and down at will, right? And the reason why this is important as opposed to virtual machines is that virtual machines are at a coarser grain level. So you can't spin them up as fast as you can spin up containers. Furthermore, also, they take up more space in terms of resources. If you have a small microservice that only takes up this much, but that's the part that needs to be scaled, you can scale that much more readily, right, and find a space for it to take up some CPU and memory much more easily than you can do with a VM. So it gives you a finer grained control over your scaling, both up and down of your software.
Okay, the L in CALM stands for lean usually, although I've seen it in literature standing for learning, but I chose to stick with the lean. So what is your role as an architect in a lean organization, right? And I think that my favorite role is the value stream mapping to really help your team understand where their bottlenecks are, where their wait times are, where they should focus their process improvement. And the other part, as the architect, often is just advocating for the teams that want to make change and helping them prioritize. So if you take a look at the lean principles of work in progress, what I see on teams is that some people will get enthusiastic about making changes and they try to speed up certain parts of the process, but what that's doing is just leaving more work in progress, waiting for the next step to come along. And so as the architect, you can really help them understand where they should improve that. The other thing is that if you're truly going to DevOps, then you want to do feature-driven development. And so that means all the way back at the requirements and architecture time frame in the life cycle, you want to be focusing on the documentation around features rather than around big functions or components in the system. So that would be a shift at the very front of the system engineering V. And then the lean kata work, right? I mean, this straight from Mike Rother. You go through this planning phase. How do you actually change your team over from a more legacy type of development? And so you got to think about that. You have to understand where you are today. You have to understand where you want to go to, but that value stream mapping will help you figure out what that next target is, right? So we like to think of this as a nice, orderly progression through the transformation. But the reality is it looks more like this, right? And that gets back to that culture of experimentation. So you identify where you want to go. You figure out the next thing you want to work on, and you start some small experiments there. And some of them work and some of them don't. But generally, we're making this upward progression. All right. Back to you, Eric.
Can you hear me? Okay. And if I have beard obstruction there. So the last stage is called measurement. So measurement in Calm can be achieved also via microservices. Many microservice frameworks, Dropwizard, Spring Boot, and Cloud, as well as Wildfly Swarm, and there are others now as well, feature built-in standard metrics that you essentially get for free and that you can read in order to achieve a measure of software resiliency, right? So responding to degradation in downstream software. How did Netflix, during the AWS outage in 2011, still maintain their level of service to their customers? So they turned off some features, but the basic feature of streaming movies was there, and they were able to keep going, right? So how do you respond to those metrics? But in order to be able to respond, you have to have the metrics in the first place. So those are built into microservices and enable us to proactively determine if our services, if our software, our VMs, or even our hardware, and there's various hooks to be able to do that, both in cloud and non-cloud environments, to tell if they're getting sick. What does it mean they're getting sick? It means that they are deviating from some sort of norm, right? And typically that's via what we call a Gaussian distribution, as you see here, right? And then we automatically respond to that. So sometimes you don't get a Gaussian distribution. Sometimes you get metrics that actually show patterns, but those patterns are actually spikes at regular intervals, which would not be found via most Gaussian distribution analysis. So what can you do about that? You use a technique, it's called fast Fourier transforms. It's a mathematical technique, and that is built into software such as Scryer, which is from Netflix, which will actually enable you to do correlation of events that are non-Gaussian, non-standard, and define those patterns. The other thing also, which is important to mention, is that when we have metrics, whether they be software metrics, hardware metrics, things from our infrastructure and so forth, independently they may not point to a problem. But when you correlate them together, you can not only find that there is an issue, but also the source of the issue, and you can get that information quickly. So there's a need to be able to intelligently correlate our metrics. And in addition to that, once we have that information, we need to route alerts intelligently to the right people and to collate thousands and thousands of alerts into one alert to the right people such that it doesn't get ignored and it gets acted upon promptly. There's software to do that, such as PagerDuty, and then you have software to monitor your infrastructure, such as Nagios, and to automatically respond as well. But also, there is, as mentioned earlier, the ELK stack, which stands for Elasticsearch, Logstash, and Kibana. What's important about these three is that Logstash, or similar software such as Splunk, will take your logs and it will put them into a centralized place, so you don't have to worry about the fact that your software is distributed. But also it will transfer your logs in a way that makes it easily searchable via a tool like Elasticsearch that can automatically plug into another tool such as Kibana, your graphing tool, or here we show Grafana, which is another fine tool for that. And through those different inputs, those different data sources being correlated into a graphical display, you can see at an instant what's going on with your system at all different levels. And also, via those transformed log messages, you can also automatically program response to those to automatically heal via scaling of your services, moving your services over to other resources, or even scaling down your services. In the case of Amazon, you may want to scale down resources because you don't want to pay for resources that you're not actively using. Oh, go ahead.
Yeah.
With a conclusion too? All right. Bonus round, guys. Okay, so yeah, as noted here, we need to understand the whole system up front. We do have a different role nowadays, but it's still an ongoing, very important role. As a matter of fact, it's very exciting because we're the ones that really push the change in the organization, right? Many people, as Terri brought up, they feel very comfortable, you know, status quo, let me get to my retirement, right? You have to push these things. You're not always going to be most loved for it, but you're going to achieve some cool effects, right? And that requires us to stay current on these latest patterns and many others that support automation in the cloud, and also understand that our role extends beyond just the software. It includes test. It includes our infrastructure, right? It includes all these things working together to deliver software very, very quickly and in small batches. Okay, thank you.
Any questions?
I'll throw one out. Hey, so in breakdown, when you turn on feature functions, do you typically take those through change management, like request a change ticket to, sending it that turns it on?
You mean a feature flag?
Yeah.
So that's something that would be built into the code, right? And then the turning of that would be a function of operations or of your test group.
He's saying, do you have to take it through a board?
Oh, to do it through a board.
Yeah, through change management.
Yeah, so like
Yeah.
I said, we
Yeah.
have 100 plus different programs, so every program would handle that a little differently. It's,
Yeah.
it's not an easy, right? The customer is risk averse, so that's something that some customers are starting to embrace once they start to feel the, that you have the process nailed, right? And you're delivering quality, and others remain risk averse. So,
And-
certainly going to a missile, you're not going to be in it automatically, right?
No. Oh, you'll be delivering automatically. No, but I will also add that it's important in what we do to also convince people that you can codify that knowledge. Because what a board is really a check for certain things. So if you can transfer that and codify it, then that becomes something that can be executed and allows you the self-service to be able to turn on and off things.
Great.
Okay.
Thank you very much, guys.
Thank you.